Hello everyone, and welcome back to All Things Space. The Sun is a 4.5 billion-year-old yellow dwarf star, a hot glowing ball of hydrogen and helium at the center of our planetary system. It's also the largest object in our solar system, meaning the Sun's gravity holds everything together in orbit, from the heaviest planets, asteroids, and comets, to the tiniest bits of space debris. As we all know, the Sun is also the primary source of heat and light in our planet, without which life would simply cease to exist. With the advent of solar panels, energy from the Sun is currently being used to generate renewable or green power. But what if solar power stations were built in space? How close to the Sun would we build them? What if we encircled the Sun with solar panels? Here's everything you need to know. Number 5. How much energy does the Sun emit? Located approximately 150 million kilometers from Earth and 26,000 light-years from the galactic center, the Sun is the largest entity in our solar system. It's about 100 times wider than our planet and about 10 times wider than Jupiter, the largest planet in our solar system. The Sun is so enormous that its volume would need 1.3 million Earth-like planets to get filled. Given its size, it's no surprise that the Sun can generate astonishing amounts of energy. It releases heat and light at a mass energy conversion rate of 4.26 million metric tons per second. To put that in perspective, it's enough energy to power 2,880 trillion light bulbs and still have enough electricity in 1 hour of sunlight for all those bright bulbs to shine for at least 24 hours. But where does the Sun's energy come from? Like every other star in the universe, the Sun can generate energy through the process of nuclear fusion. During nuclear fusion, hydrogen within the Sun's core is readily converted into helium, due to which mass is converted into heat and light energy. But getting this energy from the Sun's center all the way to our planet through multiple layers, each of which ensures that solar energy gets to where it can help create and sustain life. As mentioned before, the Sun's core is the innermost part of the star where all of its energy is centered. The core contributes to nearly 20% of the Sun's mass, and temperatures here can easily soar to 15 million degrees C, making it the hottest part of the Sun. The core is the only part of the Sun that produces an appreciable amount of heat through nuclear fusion, and by 30% of the Sun's radius, fusion stops almost entirely. This means that the successive layers, namely the radiative zone, convection zone, and the Sun's atmosphere, are all involved in the transmission of heat and light energy into outer space. Let's talk about the radiation zone first, which is the zone immediately next to the core and extends up to about 70% of the way to the surface. Here, energy from the core radiates outward until it reaches the next layer, the convection zone. This is the Sun's outer layer, where temperatures are lower than the radiative zone, allowing the development of convection currents. Next comes the visible surface of the Sun, or the Sun's atmosphere, which comprises the photosphere. This is where the Sun becomes opaque to visible light, and where sunlight and heat that are radiated and convected start emitting into outer space. According to scientists, the Sun is a little less than halfway through its lifetime, which means, like all stars, it will eventually run out of energy. When that happens, the Sun will expand exponentially, engulfing multiple planets, possibly the Earth as well, before it eventually perishes by becoming a white dwarf. Number 4. What is solar power, and why is it important? According to the U.S. Department of Energy, 173,000 terawatts of solar energy strike the Earth continuously, which is more than 10,000 times the world's total energy use. But only 4% of that massive amount is used to generate electricity or renewable power. By definition, solar energy is a form of renewable energy obtained from the electromagnetic radiation from the Sun. It's harnessed using an array of technologies, mainly solar power, the use of which has steadily grown over the last few decades. In 2017, the International Energy Agency showed that solar had become the world's fastest growing source of power, and since then it has continued to revolutionize renewable energy and make an impact around the globe. There's a long list of advantages associated with solar power, which is why it stands front and center in the development of sustainable energy resources. For starters, solar power is an inexhaustible, non-polluting source of energy that represents a clean alternative to electricity from finite fossil fuels, petroleum, and natural gas. Given the growing concerns about climate change and global warming, solar power is an effective way to reduce your carbon footprint and contribute to an environmentally sustainable future. It also reduces electricity consumption and overall cost, enabling you to control your own bills and energy usage. Furthermore, with solar power, we can use underutilized land. For instance, a 45-acre solar farm has been recently built in the UK, and it's able to power 2,500 homes. Number 3. How do solar panels work? In the context of solar power, solar panels are the main site of electricity generation. They're the main unit of solar PV that has now become renowned as an inexpensive, low-carbon technology. In simple terms, a solar panel works by allowing photons or particles representing light or any other form of electromagnetic radiation to knock electrons free from atoms, thus generating a flow of electricity. Each solar panel is made up of many smaller units, called photovoltaic cells or PV cells, that are sandwiched between layers of semiconducting materials, such as silicone. All of these layers, in turn, establish an electric field so that when a photon of sunlight knocks an electron free, the electric field will push that electron out of the silicone junction. In physics, this is known as the photoelectric effect, the main principle behind electricity generation in solar panels. Number 2. What are solar power stations? Before we get into what solar power stations are, let's talk a bit about what happens to the electricity generated in PV solar panels. This form of electricity involves a direct current, DC, which is then sent to a solar inverter so that it can be converted into alternating current, AC. Alongside converting DC into AC, solar inverters provide ground fault protection and track voltage, current, energy production, and maximum power consumption. In recent years, microinverters have brought tremendous improvements to the PV industry. With microinverters, each solar panel can now perform at its maximum potential, generating even more electricity than before. Previously, a central inverter would slow down the entire solar array in case of a problem. Now, if there's an issue with one solar panel, the rest of the solar array can still perform smoothly without any complications, all thanks to microinverters placed within each solar panel. These solar panels are connected to other solar components within a large-scale grid of connected photovoltaic power system called a PV power station or a solar power station. There are various types of solar power plants, such as on-grid, off-grid, and hybrid, that conduct electricity transmission to homes, businesses, and various locations. Number 1. What if we put solar panels around the sun? Finally, let's talk about the possibility of using solar panels in space. Space-based solar power isn't an entirely new concept, since space experts and researchers have been working on it for quite some time. As compared to terrestrial solar panels, satellite-based solar panels would be able to capture and transmit 30% more solar energy, because factors like atmosphere, clouds, and nighttime would no longer be a hindrance. According to world-famous space agencies such as NASA, a space-based solar power system would need a solar power satellite, an enormous spacecraft equipped with solar panels. These panels would then generate electricity, which is then wirelessly transmitted to Earth through high-frequency radio waves. However, for such solar panels to effectively work around the sun, they would require ultra-light solar cells, not to mention space robotics and multiple space shuttles needed to assemble the entire solar power system. Damage to solar panels from space debris and transmitting electricity from space to Earth are other challenges that scientists are currently facing while developing a satellite-based solar power system. And that brings us to the end of this video. Don't forget to like, comment, and subscribe to the channel with notifications turned on so you don't miss out on any of our latest uploads. We'll see you soon. Until then, take care and goodbye.